Sauce here. This is a video lesson for Python programming, sound. And what we mean by sound is loading files, wave files in this case, that can be music or sound effects, and then playing them inside of our code. This program was begun with the stub0 file. So there are many basic things that have already been written. I've added a single color in a section before my frame loop begins. The color white will be used. The tuple of 3, 255, 255, 255. I've also changed the caption to the name of this lesson, sound. At the top, I'm going to import a couple more things to make use of. I'm going to import the OS module. OS is for operating system, and we've used the getCwd function, get current working directory, in order to find the directory on our computer so that we can, in this case, we're going to load files, sound files, from that location. I'm also going to import random and use that within this program. Pygame.init initializes Pygame. That's necessary because all computers are different, and when you are using the Pygame module, you need to interact with display, often the keyboard, and peripherals that can be configured differently. So initializing looks at your system and prepares the code to deal with your unique system. Well, we could make use of the sound cards and chips on our computer. Sometimes it's unnecessary to initialize the mixer, which is the controlling the sound hardware components on your computer, but it's a good idea to run pygame.mixer.init at the top of your file in case it is needed to initialize so that things will work. So we have that at the top of the file. I have on screen, as part of this lesson, the folder that my code is inside of. This code file that I'm writing for this program is located in a file on my computer. In this case, the file is cppgex4 sound. If it hasn't already been said, cppg stands for Computer Programming Python Graphics, which is the lesson collection that these videos are about. And this is example 4. Inside that folder, I have my code file that I'm writing right now. I have 2 versions of it. You'll only need one when you work with yours. I have a version that is prepared for these video lessons. So I'm explaining this so that you can see the files that are on my computer, because preparing the file structure when you begin to use resources like sounds and graphics and other code files, that file structure on your computer is very important. And we want to organize it and get used to organizing it well and reliably and consistently. Part of that organizing is I have a folder in the location of the code file, so it's a subfolder for this program called sound effects. And in that folder, I've put 5 sound resources. They're all wave files. There are 5 of them. In this computer program, we're going to load 2 of these files that are located there. So let's do that. Under the screen settings section, I'm going to add a comment that will become part of the regular stub, but we're doing it for this first time. The comment is load resources. This is the best place in the code to load sound and graphic files. So to prepare to do that, we're going to run this, or we're going to include this familiar line. Path is equal to a call to os.getCwd. This gets the current working directory, the location on your computer, which is unique to every computer, where this code file is located, because we need to use this location to find the sound files that we're going to load. And we assign that equal to path. So now the variable path can be used to represent that location. I'm going to call from Pygame, from the family of functions called mixer, the sound function. Sound is capitalized. we often capitalize functions that are names of class. Sound is capitalized because we are literally making an instance of class sound. So this instance will be the file, the sound file that we're going to load. The argument of the sound function is then a string, which is the precise location and name of that file that we're loading. And we get that precise location by first starting with the path, but that's a variable, so we need to represent it in our string as a %s. Now we're not going to load the file from the path, because the path is where this code file that I'm writing now is located. And the sound effects or sound files that I'm going to load are inside a subdirectory in that location. So I need to begin with the path, but then also include a slash to include another folder called sound effects that I've made. I have to use an N and spell it correctly. And then inside that subfolder, another slash, which will then, after that last slash for the complete directory location, comes the name of the file. And I'm going to load two of these. The first one is going to be the adventure song. I could click on the file. I'm in the habit of doing this to get it spelled exactly right. Sometimes these file names are long. Click on the actual file, copy it, and then paste it. But we also need to append the file type, and this file type is WAV. WAVs are the most stable file and, in my opinion, best way to load sound resources. Pygame can load MP3s. Sometimes it's problematic. Sometimes it's the file itself. It might play in another audio player, but then not be loadable in a Python program. I'm not sure why that happens, but it happens often enough that I convert all MP3s to WAV types before I use them in the programs that I write. So after the string, we need to supply the value of the path with that convention of completing the string. This Pygame mixer.sound call is now loading that file, if the file can be loaded. But we need a place then for that file information to go. So we're going to use a variable then to represent the instance of the sound file that just got loaded and created. And the variable, it's best to be descriptive, in this case is going to start with music underscore ADV for adventure. And in case I could load other music files, I'm going to say also underscore 1, the first adventure music file used in this program. All right, let's repeat that for a second file. I'm going to copy this line because it has lots of useful information, but I'm going to change the name of the file that I'm loading, and I'm going to load sfx hit click with underscores. So I copy that file name that's ready to go, paste it in there, and we need another variable to represent the file that we are just now, or the instance of a sound that we're just now creating. And I'm going to choose sfx underscore click. This is a variable, of course, so we can't use spaces. That's why I use underscores, just like we should be in the habit with our file names. And I use sfx for sound effects. I always start the variables that represent sound effects with music and sfx to distinguish them when I'm coding. It's a very good habit to be in. I have now 2 sound files loaded. We're almost ready to check to see if this is loaded and works. And a way to check is I'm going to refer to the variable music adventure 1 with underscores, and I'm going to append the function play to it. This means play that sound if the variable represents the sound file. I'm going to save and run now to check my work. We have adventure music playing. Adventure music that was made by somebody local to the Mendocino community where these lessons are being prepared. Okay, very often sound files do not load, and sometimes it's because the sound file itself just cannot be incorporated into Python. It might play in another music player, but not be importable or loadable. There's nothing that you can do about that, though converting MP3s to waves might help. Very often, the use of these slashes inside the path is problematic because a slash also signifies a new line character. So if a slash is confusing the path name, then it's recommended that you go to try the different slash, the slash in the other direction. Sometimes we could change the name of the sound file or directory. If we have a /n, it might be confusing it with the new line character. So not using n's and some other key letters might fix it. Very often adding a second slash, so if it's a new line character, it's literally then the character that is the slash that you need, will work out. Sometimes you don't have control of the slashes that are being used, especially if you're using the getCWD for the path. It'll come in, or another resource will make that path information use problematic formatting. There's almost always a way to deal with it, but in dealing with creating the path, it doesn't work. Even though you've tried everything, then we have to consider that the sound or graphics file is not loading because it's something problematic with the file information itself, and there may be nothing you can do about it. Okay. We have nothing happening in the graphics screen. We have a black rectangle that needs to be there to play sound because it's the Pygame module that is including the ability to play sound files. But we can do something with our graphics as well and associate a sound with graphic changes. So we're going to prepare something simple. And a comment to begin. We're going to count frames, and then we're going to make a dot every so often. That's our intention. So what does it mean to count frames? We're in the frame loop. Now we're coding inside the block of this while loop, which we call the frame loop. Remember that graphics programming is like a film, where we create still images very quickly and show those images in a sequence to give the illusion of motion if the image changes. Now we start with a black frame, and the way we're going to change it is we're going to every so often put a white circle on top of that black frame. And the way we're going to control the pace of this, we're not going to put a circle every frame, that would be very fast. We're going to count frames. We have a variable previously initialized or declared called frame, and we're simply going to add 1 to it every time this while loop iterates. And then we're going to write a condition that if the frame is greater than 500, 500 is arbitrary, you can change this number to be higher or lower in order to control the pace of what we're doing here. But on condition that frame has counted up from 0 to 500, then we will immediately subtract 500 from frame. We're also going to do something else in this code block. But right here, to be clear, the code that's written is a way of controlling time. The frames are going to slowly count up. Once they get to 500, it goes back down by 500 and starts counting up again. So this is like a trigger effect. However long it takes for the frames, this while loop, to iterate 500 times, then we'll get inside this code block and it'll repeat fairly regularly. So what are we going to do inside this code block? We're going to draw circles. A circle, it's going to be white, the color that we prepared, but also needs a center. And we're going to make use of the random module to find a center location for our circle on the screen. and I'm going to give it as put an n in there. So from the rand range function, from 30, and we're going to make use of the screen width, which is part of the stub. Screen width is known, if we spell it correctly, minus 30. So this is a clever way of getting at least the horizontal component of the center of a circle to be on the screen, but with some borders. It's going to be within 30 from the left and within 30 from the right with an argument like this. And then we need to do that for the second component of that coordinate, the y component of the center, but we're going to change it to screen height. So the center x and center y now represents a randomly located center of a circle that's guaranteed to be on the screen, and even inside the screen, not on the edge, because we've gone from 30 to 30 less than the dimensions of the screen. We're going to draw a circle there. So pygame.draw.circle is the function, and the argument for a circle is where it's going to be drawn to the screen, the color, so we've prepared that color tuple white, then the center of the circle, which we have just established as center underscore x, comma, center with an n, underscore y, wanting to check something. And then next part of the argument is the radius of the circle. Let's say it's 20, and then the line thickness of the circle that's drawn, 0, it will be to fill that circle in. We now have, hopefully, a circle being drawn. I'm going to save this and run. We'll check our work. Adventure music playing. Screen height is not fine, probably because I misspelled it. So I'm going to comment out this music playing so we can focus on our circles being drawn, but we're going to get back to controlling the music, turning it on and off through our code. And I got an error that I misspelled probably the screen height. So I'm just going to copy and paste it there, and it did switch the E and the I. Let's check the work now with the adventure music turned off, and we have random circles being drawn, but not extremely fast, at a pace that's being controlled by the frames, the frame rate, every 500 frames in this case. Okay. Why did we do that? Because we have another sound, in this case a sound effect, to play. Every time a circle gets created, we're going to play that clicking sound. So we have a variable that represents that instance of the sound file, sfx underscore click. If we play it right here, and it's a short file, if we play it at the same time that a circle gets drawn, then it's going to create the illusion or the effect that every time a circle pops up, then we play this file. Let's see if that works. Click, 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 at the same pace that the circles are being drawn. So we're associating a sound with a graphic effect, something that is a common thing to do in interesting programs. Now let's deal with that music that's being played. We want to be able to we want to be able to control sound files not just by playing them, but by also stopping them as well. A sound file, when you use the play function on it, will play until the sound has concluded. And of course, sound files are of various lengths, so our sound effects play in various lengths. Sometimes we want to be able to control a sound by turning it off before the file has finished playing. The one way to do that is we're going to write a new block of code, is we're going to count those circles. We're going to call them spots. And every time we create a spot, we will increase the spot number by 1, just like we did frames. So if we're going to do that, we're going to modify spots. We need to set it, in this case, equal to 0. So we've created this variable that will be used as a counter as well. And then we're going to write a block of code, and we're going to say every 20 spots, toggle the music. If it's on, turn it off. If it's off, turn it on. So what does it mean every 20 spots? Well, we have spots set at 0, and if we're inside this code block, it's creating a spot, so spot number is going up by 1. And we could say, if then the count of spots is greater than 20, so every 20 spots, then we'll do this code block. And just like the frames, we're going to immediately decrease spots by 20. This creates a timed regular counter effect. Spots is going up, and when it hits 20, this code block will run. Part of the code block is subtract 20. So it goes up to 20, back down, and then keeps going up. So we have this timed regular counter effect. And what are we going to do? We are going to run a condition which will include a call to, gotta spell it right, so it's going to work, pygame.mixer in the family of functions mixer, stop. And a comment for this will silence all sounds that are playing. All of them. No, we don't want to stop yet. We're going to check on condition and use the get busy function first. So we haven't silenced them all. By calling this function in the condition, what we're doing is we are establishing whether sound effects are being played or not. Is the mixer busy? Yes or no. It's a Boolean. And if it is busy, then we're going to stop. Stop everything. And if it's not busy, so an else, if the condition of the get busy was false, meaning no sounds are being played, then we want to play a sound. In this case, music, adventure 1, play it again. So here's the intention of this code. We have a counter that is going to do this periodically. But once it triggers every 20 spots, it's going to check to see if the mixer is busy. The mixer is controlling sound effects on our computer. If it's actively playing a sound, any sound, then get busy will be true, and it will stop all of those sounds. But if the mixer is not busy, which means no sound is being played, then it will play the music file. This should have the effect of if you hear something, then it'll turn it off. If you don't hear anything, it'll turn it on, specifically the music. Let's see if this works. Not quite, but why? We have to add something to our code. What's not happening is the music, the adventure music, is not playing, but we do hear the sound effect, that clicking sound. Now, the clicking sound is a short sound file. It's very, very brief. So often the sound file for the click will end, and so any query to see if a sound is being playing will be false because the file was so brief, it stopped playing already on its own. But we didn't hear the music. Is that because we didn't play it? Well, we can uncomment this. The music didn't turn on. We're going to uncomment this. So it starts playing at the beginning, and then we'll see what happens. Does it toggle? it didn't start again. Why? Our music file started before a frame loop, so we began playing the music. Then we got into our graphics processing when our code started the frame loop. We did experience that after the music was playing and after 20 dots had been drawn to the screen, then it did stop. We heard the music stop. The sound file for the music is quite long, so it would have played if it didn't get this command to stop. But then it didn't start playing again. And the reason for that is because even though the click sound file is very brief from the human experience, it's long. It's a very long click sound effect from a computer processing experience. In other words, this was always true because the computer code is going so fast. The clicking that was done before it is always something that is registered by this get busy check. In other words, it's always busy. It may be busy with the music file, which is long, but it's also busy with that short music file because the code is processing too quickly. So how do we fix this so that we can get the interaction that we want? We have two sounds being played, but we want to really only deal with and control the music file on or off and not have the sound effect file confuse our intention. So here's how we get around that. When we play, we could assign a variable to be equal to the playing of the music file. And this is a good habit to be in, even if we don't use the benefit of assigning a variable to be equal to the playing of the music file. Now we have, so music channel is equal to the playing of the music file. That means that this variable represents the channel that the file is playing on. There are multiple channels. I believe that there are 8 that are established whenever you begin a Pygame sound mixing program. 8 by default. You can make more if you need them, but we need separate channels because we can play multiple sound effects on top of each other. We play the music, we play the sound effects at the same time. So our computer hardware is playing those in different channels that are independent. So we can control those channels independently if we declare variables to represent them. Now I can print right now what music channel is, so we can see what our code thinks of it as. And of course, we take a look at the output of that print. It's a channel object. So those channels exist, and here's how we make use of it. In our code, where we're wanting to toggle the music, we are going to first, before we check to see if it's busy, well, we first have to also make a channel for the sound effect that got played here. And we're going to call the variable that will be equal to the sound effect. We're going to call that spot channel. The process in our computer that's dealing with the playing of that specific sound effect. Now that we have channels for both, we can make use of the spot channel by turning it off before we check if our mixer is busy. And then when we play this music, we are going to give it the same music channel when we play it again. So here's how our code has been modified. We assigned variables to be the channels that the sound effects are playing so that we can stop the sound effect channel before we test if the mixer is busy. So it's only going to detect whether the music is playing or not. That's the only thing after we stop the sound effect that could be playing. music was turned off and turned back on again. We also did not have an interruption of the sound of the clicking happening because our human perception isn't able to detect the timing of it in that precisely. So here, that's a way to control different sound files and start and stop them. Now you have seen how to organize the resource, if we include an R, the resource files for a program, load sound files and play them. Prepare to write a simple program by first creating a sound effects folder in the same location as your code file and placing the 2 sound files that accompanies this lesson into that folder. Specifically, the sfx_bow_twang wave and song intro wave. Write a simple program that loads those files and asks for user input using the input function. Toggle the playing of the music file if the user enters M, and play the SFX file if the user enters anything else. Your user will interact with the text-based interpreter, but it will work. So this program, to be clear, is going to practice loading a couple sound files, different than the ones that I've used in the example, but there are 2 of the sound files in the same folder. And asking the user for input, not graphics user input yet. That's we're going to do that in the future. But for example, what this is looking for is that old call with a prompt, something like this. And when you run this, I'm going to show you, the graphics window will run, but we can still interact with idle and the user can still make choices. This is not the exciting graphics user interface that we will learn to program with, but it is a way that you can ask for user input and then respond to it. In this case, the response will be playing a sound effect or music. Have fun.